Howdy, AP PreCal. It is Miss Kosh. I wrote this problem after seeing something similar on AP Classroom. Actually, I was a little bit inspired by a problem I saw in my IB stuff also. So this is kind of a merge of AP and IB all in one problem, and it's great fun. So I may not have the verbiage perfect to AP Classroom, but it's good enough and it'll get you through. Okay. So let's say alpha is an angle whose terminal side intersects the unit circle at the point PQ. And beta is a same idea, an angle whose terminal side intersects the unit circle at the point ST. So I went, for the sake of time, I went and drew, here's a little alpha, and it's where it hits the circle, it's going to be the point PQ. And I drew beta, and where it hits the circle is ST, and it doesn't really matter what quadrant or any of that kind of stuff, but here we go. Okay, and then it tells us that theta is equal to 2 alpha plus beta. And they want us to find the coordinates where theta intersects the unit circle. So if I were to take 2 times this angle alpha and then add it to beta, you know, then I'd be, where am I, what are my coordinates? Well, so keep in mind, pause if you think you can do this without me, because I'm going to jump right into the problem. Keep in mind the x coordinate is the sine of that angle, and the y coordinate is the cosine of that angle. So it might be helpful to write down that cosine of alpha is equal to p, and sine of alpha is equal to q, and then likewise cosine of beta, that was this angle, is equal to s, and sine of beta is equal to t. Okay, so now we have all the component pieces based on these two angles, and they want us to find where they want us to find the x and the y coordinates for the angle theta. Okay, so the x coordinate is always cosine, and the y coordinate is always sine. So to find, so what I did down here, I already worked through some of this. The x coordinate is going to come from cosine of 2 alpha plus beta, because that's the angle we're looking at. Well, this was technically, this was cosine of theta, which theta was equal to 2 alpha plus beta. So then I said, well, the cosine sum and difference is cosine, cosine, sine, sine with the opposite SIGN, cosine, cosine, sine, sine with the opposite SIGN. And then I realized, well, I don't know anything about cosine of 2 alpha or sine of 2 alpha, but I have formulas for those. And I decided to use, I don't think it really matters which one I use here, but I used two. It would matter if this shows up in multiple choice because it would have different letters and variables and stuff. But if it were free response on my test, I would accept anything that made sense. So you could use, I went with the 2 cosine squared alpha minus 1, but you could have done 1 minus 2 sine squared alpha, or you could do cosine squared alpha minus sine squared alpha. What did I just say? I'm just talking about how cosine of 2 alpha has 3 different versions of the equation. It could be cosine squared alpha minus sine squared alpha. It could be 2 cosine squared alpha minus 1, or it could be 1 minus 2 sine squared alpha. If this does not make sense to you, go back and watch my previous video, but I have been pointing out to my students that the cosine is always positive and the sine is always negative in this identity. I would think we could come up with different versions of this final answer depending on how we substitute it here. Let's do one version and call it good. So if this showed up in multiple choice and it was something like this, and you picked a version here that did not show up in the multiple choice, well, then go back and pick a different version and try again. Okay. So then the y coordinate would end up giving you a sine of this is sine of theta, which would be sine of 2 alpha plus beta, which sine breaks apart to sine, cosine, cosine, sine with the same SIGN. So it's sine, cosine, cosine, sine with the same SIGN. So it was sine of 2 alpha cosine beta, cosine 2 alpha sine beta. And then this one, I just switched it up just for the fun of it and decided to use this variation on that identity. For no reason, to be perfectly honest with you. I just wanted to do something different. So same idea as before. Okay, so if we were cleaning this up, this is 2 times cosine of alpha squared minus 1 gets multiplied by cosine of beta minus 2 times sine of alpha cosine alpha sine beta. Okay, now what in the world are all these things? Cosine of alpha, we wrote down way up here. Cosine of alpha is equal to p. So I have a cosine of alpha, there's that, there's a p. Do I have another cosine? Here's another cosine alpha, and so I can plug in that p. Then I have a cosine beta. If you look right here, cosine, nope, look right here, cosine beta is S. And cosine, nope, that's the only one. And now I need sine alpha and sine beta. Well, so sine alpha is Q, sine beta is T, sine alpha is Q, sine beta is T. Okay, and so somehow you would have to clean this up. And this is definitely, I made a harder version than what I saw in AP Classroom, but I thought it was kind of fun. I mean, you could probably say, I mean, if you wanted to, 2p squared s minus s minus 2qpt or something like that would be this would be the x coordinate. Ay. That's kind of a beating, but there you go. This is a version. It's not the only version, as we mentioned. Okay, so then the other one, this breaks apart. Sine of 2 alpha breaks apart to 2 sine alpha cosine alpha. Then it's getting multiplied by cosine beta. This, I used this version this time, and it's getting multiplied by sine beta. So now it's 2 times something times something times something plus 1 minus 2 times something squared. Close that parentheses times something else. Oh my goodness, that's a lot of somethings. Sine of alpha, I'm looking up at the top, is Q. Cosine of alpha is P. Cosine of beta was S. If you don't remember, it's all written right there. I can see it, but you cannot. I'm sorry. Sine of alpha is Q. That gets Q squared. Sine of beta was T. And so maybe you could expand this out to, well, P, Q, S. Maybe we do them in alphabetical order. I see a positive T, and then I see a negative 2Q squared T. And that is so if we were to write this as an ordered pair, the ordered pair, the x value would be something. Can you see all of what I'm doing? How about now? Okay. The ordered pair, the x coordinate would be like this: 2p squared s minus, I'll put it in alphabetical order, 2pqt. That is ridiculous. The y value would be 2pqs plus t minus 2q squared t. Okay, that is more difficult than what I found on AP Classroom, but if you can do that, you can do anything. Like, subscribe, comment, and go practice. Good luck.